Hello everyone, Bill Nye here, and today we're going to tackle some of the wildest stories swirling around the Cascade volcanoes. The Cascade Range is a breathtaking stretch of mountains, home to some of the most powerful and fascinating volcanoes in the United States. These peaks have shaped the landscape for thousands of years, and they continue to capture our imagination. Recently, you might have noticed a surge of rumors online, everything from secret magma tunnels running beneath the surface to claims of a sudden red alert from the USGS, and even fears that one eruption could set off a catastrophic chain reaction. It all sounds like something straight out of a blockbuster disaster movie, doesn't it? But real science isn't about panic or hype. It's about careful observation, evidence, and understanding how nature really works. So let's take a closer look and separate the facts from the fiction, one step at a time. We'll dig into what actually makes these volcanoes tick, and find out what the real experts at the USGS are saying, not just what's trending online. Are there really vast networks of magma tunnels connecting these volcanoes, or is that just a myth? And what about that so-called red alert? Is there any truth to it, or is it just another internet exaggeration? Let's get the facts straight from the source. We'll take a closer look at Mount Rainier and Mount St. Helens, two of the most closely watched volcanoes in the region, and of course Mount Hood, each with its own unique story, history, and potential risks. Understanding these giants is essential for the people who live nearby, and for anyone who wants to appreciate the power and beauty of our planet. We'll also see how real scientists keep a close eye on these mountains, using advanced technology to monitor every rumble and tremor, and what you should actually be concerned about, if anything. Sensational headlines and viral posts can spread quickly, but the real story often takes a little more digging and a lot more science. So, let's put on our thinking caps, become geological detectives, and uncover the truth together. Ready? Let's begin. Meet the stars of the Cascade Volcanic Arc, Mount Rainier, Mount St. Helens, and Mount Hood. These three iconic peaks aren't just beautiful, they're powerful reminders of the dynamic forces shaping the Pacific Northwest. The Cascade Arc stretches over 1,100 kilometers from California to British Columbia, a true chain of geological superstars. This volcanic belt is home to more than a dozen major volcanoes, each with its own story. But Rainier, St. Helens, and Hood stand out as the most famous and most closely watched. Mount Rainier towers over Washington, covered in more glacial ice than any other Cascade volcano. That ice makes it especially hazardous. An eruption could trigger massive mud flows called lahars. These lahars can travel for miles, threatening communities far downstream, making Rainier one of the most closely monitored volcanoes in North America. Mount St. Helens is famous for its 1980 eruption, which blew off the top of the mountain and sent ash across the country. It's now one of the world's most studied volcanoes. Scientists continue to monitor its activity, learning more about volcanic behavior and hazards with every passing year. Mount Hood, Oregon's highest peak, is a beloved landmark. Its last major eruption was about 200 years ago, but it's still considered active. Hood's snow-capped summit draws climbers and adventurers, while its slopes provide water and recreation for thousands. Each volcano has its own personality. Rainier is the icy giant, St. Helens the explosive celebrity, and Hood the quiet neighbor. Their differences make them fascinating to scientists and explorers alike. All three were formed by subduction, one tectonic plate sliding beneath another. This process melts rock deep underground, fueling the volcanoes above. But here's the key: they act independently, each with its own magma chamber and schedule. An eruption at one doesn't mean the others will follow. They're not just mountains. They're active, dynamic parts of our planet. Their landscapes are always changing, shaped by eruptions, glaciers, and time. Understanding their differences is the first step to understanding the bigger picture. By studying them, we learn not just about volcanoes but about the Earth itself. These volcanoes are not dormant, they're just sleeping. Their quiet moments are only pauses in a much longer story. And knowing their history helps us predict their future. Every eruption leaves clues for the next generation of scientists. So, let's get to know these giants one by one. The adventure continues, and there's so much more to discover about these living mountains. So, how does a volcano work? Imagine the Earth's crust as a cracked shell, made of moving tectonic plates. In the Pacific Northwest, the Juan de Fuca plate slides beneath the North American plate, a process called subduction. As the oceanic plate sinks, heat and pressure force water out, lowering the melting point of the mantle rock above. This creates magma, which rises slowly toward the surface, collecting in underground magma chambers. These chambers aren't giant lava lakes, they're more like spongy rock with pockets of molten material. When pressure builds up, magma forces its way to the surface through cracks, causing an eruption. As magma rises, gases expand rapidly, like opening a shaken soda can, sometimes resulting in explosive eruptions. Each volcano has its own plumbing, and eruptions are driven by their unique underground systems. That's the real science behind these fiery mountains. So, are there secret magma tunnels connecting Rainier, St. Helens, and Hood? It's a dramatic idea, but not supported by science. Each Cascade volcano is an individual system, not part of a giant underground network. Think of them as separate straws drawing from a deep source, not pipes connected together. Seismic studies show isolated magma chambers beneath each volcano, no tunnels linking them. If tunnels existed, we'd see clear evidence in earthquake data, but we don't. The rumor likely comes from confusion about their shared origins in the subduction zone. Yes, they're part of the same volcanic family, but their plumbing is separate. The idea of a shared pipeline is exciting, but the reality is more complex and much safer. These volcanoes are neighbors, not conjoined twins. Science wins over fiction, every time. Let's talk about that red alert rumor you might have seen online or heard about recently. The USGS, or United States Geological Survey, uses a clear color-coded alert system to keep the public informed about volcanic activity: green for normal, yellow for advisory, orange for watch, and red for warning. When you see red, it means a hazardous eruption is either imminent or already happening, and immediate action may be needed. So what's the real status of the Cascade volcanoes as of June 2025? Let's look at the facts. All major Cascade volcanoes, Mount Rainier, Mount St. Helens, and Mount Hood, are currently at green, which means normal, everyday background activity. There's absolutely no red alert in effect. In fact, there aren't even any yellow or orange alerts for these volcanoes right now. The USGS updates this information in real time, using a network of sensors and scientists who are constantly monitoring for any changes. If there were any sign of danger, they'd let the public know immediately. Right now, the only US volcanoes at higher alert levels are in Hawaii and Alaska, where volcanic activity is more common, not in the Cascades. For the most accurate and up-to-date information, always check the official USGS website. It's the best source for real volcano alerts. Scientists don't keep secrets about volcanoes. Their mission is to protect public safety and share information openly. If a Cascade volcano showed any signs of waking up, alerts would be issued quickly, publicly, and through multiple channels. The idea of a secret red alert just isn't how science or emergency management works. Transparency is key. For now, the Cascade volcanoes are quiet, and the experts are watching closely, ready to respond if anything changes. Trust the science, not the rumors. Stay informed, stay safe, and know that the real alerts will always come from the experts. How do scientists keep watch on these giants? With a high-tech toolkit. Seismometers detect tiny earthquakes. Often the first sign magma is moving. GPS stations track subtle swelling of the ground as magma accumulates. Gas sensors measure volcanic gases like sulfur dioxide. Spikes can signal rising magma. Satellites spot changes in ground temperature and shape, and can even see new steam vents. All this data is combined to build a real-time picture of what's happening inside a volcano. Volcano monitoring is a 24/7 job, and the technology keeps getting better. These tools give us early warnings, sometimes days or weeks before an eruption. Thanks to science, we're safer than ever living near these powerful mountains. The watch never stops. While the Cascades are quiet, Kilauea in Hawaii has been very active recently. Unlike the explosive Cascades, Kilauea usually erupts with rivers of fluid lava, but it can still be hazardous. In May 2025, Kilauea's lava fountains shot 350 meters high with ash plumes rising over 6,000 meters. Scientists tracked clear warning signs, ground swelling, and seismic activity. The Hawaiian Volcano Observatory issued timely alerts, showing how effective monitoring can be. They even issue separate alerts for aviation, since volcanic ash is dangerous for planes. Kilauea's ongoing activity is a real-time experiment, helping scientists refine their methods. The key lesson: volcanoes give warnings and modern tools can detect them. What we learn in Hawaii helps keep people safe everywhere, including the Cascades. Every eruption teaches us more. Volcanoes aren't just hazards, they're fascinating. Kilauea's runny basaltic lava flows easily while Cascade volcanoes erupt thick, sticky, silica-rich lava. That sticky magma traps gas, leading to explosive eruptions and steep conical stratovolcanoes. Volcanic eruptions can even create their own weather, pyrocumulonimbus clouds with volcanic lightning. Lava color tells its temperature. White hot is over 1,100 degrees Celsius, cooling to orange, red, then black. Not all volcanic rock is heavy. Pumice is so full of bubbles it can float on water. Eruptions can send pumice rafts drifting across the ocean. Volcanoes shape landscapes, create new land, and even influence climate. They're among nature's most powerful and awe-inspiring forces. There's always more to discover beneath the surface. Let's wrap up our journey. We started with rumors of magma tunnels and red alerts, but science gave us a calmer, clearer picture. Rainier, St. Helens, and Hood are powerful, but each has its own independent system. No secret tunnels. There's no red alert, all are at normal status, and the USGS is watching closely. The best way to stay safe? Trust official sources, not internet rumors. Living near these mountains is part of life for millions, and understanding the science makes us safer. Volcanoes give warnings, ground swelling, earthquakes, gas changes, and scientists are ready to alert us. Next time you see a scary headline, think like a scientist, ask questions, check the evidence, go to the source. The more we understand, the less we have to fear. The Cascade volcanoes are sleeping, not plotting. For now, enjoy their beauty, knowing the experts are keeping watch. Stay curious, stay informed, and stay safe. Thanks for exploring with me.